Hey guys, Marini here with another stats video. This is our first official online learning lesson. We're going to start chapter 10 now, which is all about inference for two samples of people. Chapter 8 and chapter 9, which was confidence intervals and hypothesis testing, was all for one sample. And now we're going to start two variable statistics, two sample statistics. So we have here in our do now, which is a question that we've already done previously in a prior lesson, talking about the proportion of people that would admit to walking into something while talking on a cell phone. I began this example already, and I'll finish it up with you. Remember in step 1, when we're making a confidence interval, we don't say we want to test a claim about anything. We're not doing a null hypothesis or an alternate hypothesis because we're doing a confidence interval. So we want to estimate the true proportion of all cell phone users that would admit to walking into something while talking on their cell phone. Again, no ha there. This is a confidence interval, 95% confidence interval. Step 2, this is where we check our conditions and state our inference procedure. This is a 1 prop z interval, which if you guys have graphing calculators, remember that's when we went down to letter A. Stat tests go down to letter A. 3 conditions we got to check are that it's a random sample, it's an independent random sample, and that it's approximately normal. Random, it says it in the problem, so we can go ahead and check that off. Independent, that's when we check the 10% condition, so we're going to have to assume that the population of cell phone users is at least 10 times our sample size. So we'll assume that there's greater than or equal to 10 times 738 cell phone users. And approximately normal, that's when we check n times p hat has to be greater than or equal to 10. N is our sample size, which is 738, and p hat, which is the sample proportion, that comes from the problem. There were 738 people asked, and out of that, 170 responded that, yep, I walk into stuff. So that is a 23% sample proportion. So that goes here, and that's greater than or equal to 10. Yep, it is. So now we're ready to actually do the do part, which is the estimate plus or minus the margin of error. Since this is a proportions problem, the estimate is p hat plus or minus, and then the margin of error is z star square root Okay, so the p hat in this problem is 0.23 plus or minus z star. Remember that comes from table B. This is a 95% confidence interval, so that is 1.96. Filling in the rest. Over your sample size, which was 738. All right, if you don't like that I did 0.23 parentheses 1 minus 0.23 there, and you want to put 0.77, that's fine too. Now remember, you're probably going to make a mistake if you do all of this by hand. So you go to stat and tests, go down to letter A, 1 prop z interval, and that gave us an interval of 0.20, rounding to the hundredths place, to 0.26. So then step 4, we do our conclusion. All right, so we are 95% confident that the true proportion of cell phone users that admit to walking into something is between 0.20 and 0.26. This is just review of how to do a confidence interval problem, all 4 steps. This was for proportions. We also did means, but we're not talking about that today. But now let's scroll down and take a look at how this question is a little bit different. Zoom in here. In a research poll conducted by students at Elmont, 287 out of 522 randomly selected juniors think Mr. Marini is the greatest teacher ever. All right, I think that number's a little low. When 520 randomly selected seniors were asked, 233 said Mr. Marini is the best teacher ever. So we can see here we actually have two different groups of students, some juniors, some seniors. They were asked, is Mr. Marini the best teacher ever? And a bunch of juniors and a bunch of seniors chimed in and said, yep, he is. So the first part of this question, part A, says construct and interpret a 95% interval for the difference in the true proportion of juniors and seniors that think Mr. Marini is the greatest teacher ever. So we're not looking for a confidence interval to find the true proportion of juniors that think I'm the greatest, and we're also not trying to do that for seniors either. We're looking for the true proportion of the difference to see if, the difference, or to see how different these proportions are. We're looking for a 95% confidence interval that actually has that proportion difference. It sounds a little confusing, but I'll go through the process with you guys. And again, if you have questions on it, I'll be available on Google Hangouts. So since this is a confidence interval, step one is, again, we write down, we want to estimate. All right, so far we want to estimate the true proportion. But again, we're not looking for the true proportion of juniors that think I'm the greatest teacher, and we're not looking for the true proportion of seniors. We're looking for the difference in those proportions. So we want to estimate the true proportion difference between juniors and seniors and I also like to put here in parentheses, difference means subtraction. So the order that I'm going to subtract these proportions is I'm going to go PJ minus PS. And that symbolically is the proportion of juniors minus the proportion of seniors. It's just symbols that go with this problem. And you'll see that later. PJ minus PS, that would say Mr. Marini is the best teacher ever. Okay. Now, since we actually have two different groups of people, it's wise to actually note what these two different groups are. Because above here, I wrote PJ minus PS, and the person grading this question probably wants to know what the heck that means. So I'm going to come down here and say that PJ is the true proportion of juniors that think Mr. Marini is the greatest teacher ever. And then similarly, PS is yada, 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 the true proportion of seniors that think Mr. Marini is the greatest teacher ever. All right, so that's step one. Mr. Marini, is it necessary that I do all that? Yes. Label what PJ and PS are. You could put a 1 and a 2. I just think J and S, juniors and seniors, is easier to follow. Step 2, conditions. First things first, this is not called a 1 prop Z interval. As you may have guessed, this is a 2 proportion Z interval. And the reason why I'm labeling it like this is because that's how you're going to find it in your calculator when you go down to letter B, not letter A. Random. It says it in the problem. Both of these samples of juniors and seniors were both selected randomly. Second condition, independent. Now we have to check the 10% condition for both juniors and seniors, and they have 2 different sample sizes. So we are going to assume that there's at least 10 times the sample size for juniors, 522. And at least 10 times the sample size for seniors was 520. That seems a little bit high. That's technically, 5,220 juniors and 5,200 seniors, but let's just go ahead and assume that Elmont High School is ginormous. Last condition, normal, approximately normal. All right, we can't use central limit theorem here or anything like that. That's for means. So we're going to go up. Let's see, how did we use to check that for confidence interval for proportions? Okay, n times p hat greater than or equal to 10. And then also, you know what I didn't do? I didn't check n times 1 minus p hat greater than or equal to 10 in our do now. So we also got to check n times 1 minus p hat greater than or equal to 10. So that's 738, and that would be 0.77 greater than or equal to 10. All right, nothing like messing up. So let's go down here, and let me show you how to check your conditions for two sample stuff. Now, like I said earlier, there's two different groups of students, juniors and seniors. So you are going to have to check n times p and n times 1 minus p for each one. So let me break this down. Let's go juniors, seniors. All right, for the juniors, we're going to have to check n, j, the sample size for the juniors, times p hat, j, greater than or equal to 10. And then we'll check n 1 minus p hat juniors greater than or equal to 10. All right, so the sample size for juniors is 522. And the sample proportion of juniors, p hat j, out of those 522, the 287 said that I'm the best teacher ever. So 287 out of 522 comes out to be around 55%, so 0.55, and that's greater than or equal to 10. So then that means 522 times 1 minus 0.55, which is 0.45, has to be greater than or equal to 10, and it is. Now we got to do the same thing for the senior side. So the sample size n of the seniors times p hat for the seniors has to be greater than or equal to 10. Sample size for seniors was 520. And the sample proportion p hat for the seniors, out of the 520, it said that there were 233. So 233 out of 520, nearest hundredth is 45%. So now 520 times 1 minus that, which is 0.55, has to be greater than or equal to 10. And these both work. And that's step 2. A little bit more work than a one prop z interval, but hopefully you get the idea. You got to check juniors and also seniors. Step 3, formula time. Now, it's estimate plus or minus margin of error. For a one prop z interval, which we saw over here, that was p hat plus or minus z star square root p hat 1 minus p hat over n. That formula changes now, since we're dealing with two different samples of people, two different samples of students, to this formula. And I'm going to do junior minus seniors. So that would be p hat junior minus p hat senior plus or minus z star. And now the square root, the standard error part, get ready for this. This is one of the benefits of doing this online. I don't have to hear you guys complain about this one. P hat j 1 minus p hat j over sample size j, and then seniors. All right, so that's the bad news. The good news is you're just going to plug numbers in here and then do this in your calculator anyway. So p hat j, this was the Z star comes from table B. This is again a 95% confidence interval, so 1.96. And I'll just stick your numbers there. All right, that 55 and 0.45, that's just a coincidence that it ended up being 55% and 45% for juniors and seniors. I don't want you to think that those numbers are always going to be the same. The p hat j was 55%, so 1 minus that happens to be 45%, and then just coincidentally, the seniors p hat came out to be 0.45. Now, you're going to go to stat and tests and go down to letter B, which is 2 prop z interval. Let me show you on my calculator how to get there. Hopefully this works. Okay. All right, you see, go to tests, and we're going to go down to letter B. 2 prop z interval. And it asks you for all that stuff that we should hopefully know how to do. x1, n1, x2, n2. Your confidence level is 95%. Go to calculate. Oops. And on top there we have 0.04 to 0.16. So let's put this in. 0.04 to 0.16. So that confidence interval whether 4% to 16% is the difference of the proportions of juniors and seniors that think I'm the greatest teacher ever. So step 4, your conclusion. We are 95% confident that the true proportion difference between juniors and seniors is between 0.04 and 0.16. So that's how you make a 2 prop z interval. That's all 4 steps. That's how you construct and interpret a 95% confidence interval for the difference in 2 proportions. The only other thing I want to show you guys, if I scroll down here to part B, and then once I do part B, you guys will try this one, and I'll put the answer key up, and this will be what I talk to you guys about in Google Hangouts tomorrow morning. It's about 4 o'clock in the afternoon right now on Thursday. Based on your answer from part A above, what conclusion can you make about the difference in opinion between juniors and seniors on whether Mr. Marini is the best teacher ever? So we can see that the 2 proportions are different. I mean, 55% of the juniors in this sample said I was the greatest teacher ever, and 45% of the seniors said I was the greatest teacher ever. And in our conclusion, we said we were 95% confident that the true proportion difference between juniors and seniors is between 0.04 and 0.16. What I want to show you is that I want to introduce the number 0. what would a zero difference mean? A zero difference, if zero was in that confidence interval, would mean that there is no difference in the two proportions. But does this confidence interval include the number 0? Well, our confidence interval goes from 0.04 to 0.16. 0 is not in that interval, which means that there is evidence that there's a difference, because it's actually not plausible that there is a 0 difference, because 0 is not in that confidence interval. So when you're ever asked a question like this, we can answer the question as follows. Because the interval doesn't include 0, then there is convincing evidence that the proportion of juniors that think Mr. Marini is the greatest teacher ever is different than the seniors. So because 0 is not in that confidence interval, 0 is not a plausible value. That means that there is evidence that the two proportions, juniors and seniors, is different. If 0 was in that confidence interval, then there is a possibility that the difference is 0, meaning that there might not be a difference in the proportion. But since 0, again, is not in that interval, there's evidence that the two proportions are different. And I can explain that further in the Google Hangouts if you guys have questions on that. So if we scroll down here, here's a practice problem for you guys to work on. I'll post an answer key to that sometime tomorrow morning or this morning if you're watching it on Friday, and we'll talk about it. All right, guys, later.